Hey guys, this video is my tutorial on the triangle theorems from section 4.2 in your book. I've already written the theorems down, so if you haven't, I would do that first. But the first theorem is called the triangle sum theorem. And most of you actually probably already know this information, but this theorem states that all the interior angles in a triangle add up to 180 degrees. So in my little picture here, angle 1 plus angle 2 plus angle 3, all those measurements have to add up to be 180 degrees. So we're going to use that information to help us with this first example. So we've got a map over here, and I've got a couple triangles within it. So the diagram shows us part of the survey map. They want me to find the measure of NKM. So let's find that on my picture here, and I'm guessing this guy is supposed to be N, so you might want to add that in. So we got NKM. So we're looking for this angle right here. So I'm going to put a little X in there to help me out. So I know that all three of these angles have to add up to be 180 degrees. So I've got the measure of angle M plus the measure of angle N plus this guy, and I'm going to use three letters to name that so I know which part of K I'm referring to. I'll name it the measure of NKM. I know that that has to add up to be 180 degrees. So when they're asking me to justify my first step, the reason I'm setting that up is because of the triangle sum theorem that says they all have to add up to be 180 degrees. So I'm going to call that the triangle sum theorem. That is my justify right here. Okay, and then we can continue solving because I know what angle M and N are, 88 and 48 degrees. And I'm going to leave that one as X. Okay, so we add 88 and 48 together to get 136. Then I can subtract 136 from each side. And when I do that, I'm left with 44 degrees. So, and remember I used X to represent NKM, so I'm going to rewrite that using proper notation. NKM is equal to 44 degrees. Okay? This next one says, using background knowledge, find the measure of LKJ. So let's find that here. L, K, and J. So I'm looking for this angle right here. So background knowledge, meaning I can't use the triangle sum theorem because I don't know this third angle. So I can't do what I did in that first part. But I do know that this one's now 44 degrees. And this angle, and this angle I'm looking for are all on a line together, meaning that they're supplementary. So if they're on a line together, I know that they have to equal 180 degrees. So I'm going to say that the measure of angle NKM plus the measure of angle MKJ, and plus the measure of angle LKJ has to be 180 degrees. And normally we would probably say this is a linear pair theorem, but we have three of them, so let's go ahead and call it a linear triple. Or if you wanted to put supplementary, and actually, let's actually call it this guy. We can come up with something a little bit better. If we have a bunch on a line together, we can say that that's a straight angle, so I'm actually going to put that. Definition, straight angle. But we could use, linear triple isn't a formal name, so this one's a little bit more formal of a definition, or supplementary angles would work as well here. Okay, so let's see what I've got. So I know that NKM from our first step was 44 degrees. MKJ, I'm given in the diagram, is 104, and I don't know this one, so I'm going to leave it. And I know it has to equal 180 degrees. Add those together, so we've got 148 plus measure of LKJ equals 180. Subtract 148, and we get 32 degrees is what the measure of angle LKJ is equal to. All right. Okay, let's move on to the next theorem from this chapter. This is the remote exterior angle theorem. So what the remote exterior angle theorem says is that if I extend one side of the triangle so that I've got this exterior angle, meaning outside, that those two angles that are away from that, if I add those together, they're actually going to equal this one. So in my picture, if I add angle 1 and 2 together, that's going to equal the measure of angle 4. Let me zoom in a little more so you guys can see that. Okay, so if I add these two together, it's going to be the same as this angle here. Okay, so in this picture, these are my two interior angles that are away. So you think of the word remote. Remote means kind of far away and isolated. These two are away from this exterior angle. So if I add these two together, they need to equal this angle. So I'm going to set up this equation, and it does say justify each step, so I'm going to kind of do it in a proof format here. So I'm going to say, set up my equation and say that 6x minus 1 plus 5x plus 17, so I'm adding these two angles, has to equal 126. And the reason I'm setting that up is because of what this theorem says. So the exterior angle theorem. Okay? Alright, and sorry that's cutting off a little bit for you guys, I know. So the exterior angles theorem is why I'm setting up this equation. So now I'm just going to solve. So first I'm going to combine some like terms and say 11x plus 16 equals 126. And for our reason here, you can put combine like terms or simplify. I kind of like combine like terms because it's more specific. Okay, next, subtract 16. So I'm using the subtraction property of equality. And I get 11x equals 110 when I actually do the math and simplify. Divide both sides by 11 here. So using the division property of equality. And I'm left with x equals 10 when I actually do the math there and simplify. So we've found the value of x and we've justified every single step. Okay, last theorem from this chapter is the third angles theorem. So the third angles theorem deals with two different triangles. So if I have two triangles and I already know two of the angles are congruent, so in my picture A is congruent to D and B is congruent to E, if I have that, I can automatically say that the third pair of angles, so C and F, are also congruent. Okay, so in this problem, we're going to kind of use that information. And again, I'm going to scoot this over just a little bit so that I can do this kind of proof style since I'm justifying every step. Okay, so the first thing that I can say here, I have M congruent to R and S congruent to N. So that is given to me in the picture. So by the third angles theorem, angle T is congruent to angle P, where their measurements have to be equal. So the reason I know that is the third angles theorem. Okay, so if these two angles have to be congruent, that means I can set this equation up. 2x squared has to be equal to 4x squared minus 32. So I'm just substituting in those expressions I was given. Okay, so the first thing that I would probably like to do is to get my x's all together, my x squareds I should say. So I'm going to subtract 4x squared from each side. So I'm using subtraction, property of equality there. And when I do that, I'll be left with negative 2x squared equals negative 32. Okay, so I can divide by negative 2 on each side. So division here. So when I simplify, I'm going to be left with x squared, negative divided by negative will leave me with positive 16. And here we've done a bit of this with the Pythagorean theorem and the distance formula, but I'm not looking for just I'm not looking for x squared, I want to know what x is. So I'm going to take the square root of both sides. So if I do that, I'm left with x equals 4, and this is actually the square root property of equality. We're doing something to both sides. Okay? Alright, but they're not asking me to just find x, they want me to find the measure of NPM, so that's this guy, so I do need to plug in 4 back in. So I've got measure of angle NPM equals 2 times 4 squared. So we're substituting 4 back in. Now the important part with this is I need to follow order of operations. I need to do this exponent before multiplying. So this is not the same as 8 squared. Instead, it's 16 times 2, which is obviously a lot different. So 4 squared is 16, 16 times 2 is 32. So the measure of angle, NPM, is equal to 32 degrees after I simplify that expression. All right, guys, that's the last example. Hopefully that helps you on your homework. Thanks for watching.